All right, here's part 2 of that video. And again, in the other video, we found the phase shift and we decided what we were going to do to fix our key points. Now again, remember our key points, normally there's just 5 of them, but because we're adding all those 45s in there, there's actually 9 of these. So we have 0, and then we're going to do pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And I'm not reducing this because this is just to help me, so I don't really care if it's in reduced form or not. But obviously, like, this is my pi, this is my 2 pi, and I could reduce them if I wanted to. Now, this would be 0. This is a 45, and it's in the first quadrant, so it's 1. This one I would be defining by 0, so that's undefined. -1, 0, 1, undefined, -1, and 0. And again, where I'm getting these from, we did this in an earlier video, is on the unit circle. So I have 1, 0. So again, tangent would be sine divided by cosine, which is 0. That's fine. And my 45 is square root of 2 over 2, square root of 2 over 2. Well, that gives me a 1 because I'm doing the tangent function. So I can't just read off. I have to do some math here. This is 0, 1. Well, 1 divided by 0 is undefined. So I'm just going around my unit circle to all my 45s and 90s, and I'm getting those values. That's where that comes from. All right, so now I'm going to fix my x. Okay, so I'm going to fix my x. All right, so to do that, I have my values, and I'm just going to rewrite them again. Running out of space, I need to write smaller. Alright, and so to fix them, we figured out that we would need to multiply by 1/3 and subtract that. So I'm going to multiply by 1/3 and subtract my, or do my phase shift there if you want to think of it that way. And again, with trig, you do have to be good with fractions. So if your fraction skills are kind of weak, you probably need to revisit multiplying, dividing, adding, subtracting fractions. All right. Okay, so let's go ahead and do the math here and see what we get. I'm going to go ahead and switch colors here. So this is 0, so 0 minus that is minus pi over 6. This would be what? Pi over 12 when I multiply, so I get pi over 12. And I need a common denominator, so I'm going to double. So pi minus 2 would be a negative pi all over 12. Here, let's see, I get what? 2 pi over 12. So 2 pi over 12 when I multiply straight across. Now I need to subtract. Now again, I need to double and double to get a common denominator of 12. Well, 2 pi minus 2 pi is 0, and 0 divided by 12 is still 0. So I'm going to end up getting 0 for that one. Right, and then here I'm going to multiply. Now again, I could reduce here, like the 3's cancel if you want to, but again, you need a common denominator anyway, so I don't know, you might as well just leave it 12, I think. So 3 pi over 12 minus, and again, double, so I get pi over 12. And again, I can see the pattern here that I keep adding pi over 12, so I'm pretty sure this guy is going to be 2 pi over 12, 3 pi over 12, 4 pi over 12, and so forth. But if you don't believe me, we can do the math. Go straight across here. I get 4 pi over 12 when I multiply. Again, I still get my same common denominator, and you can see that's going to be 2 pi over 12. Right, so this is going to be 3 pi over 12, 4 pi over 12, 5 pi over 12, and 6 pi over 12. And again, I'm not reducing these because these are just for me to help me graph. So what I basically did is I fixed the angle. So the nice thing now is when I sub this angle into my either function, I'll use the factored form because you can see it better. This is going to give me 0 times 3 is still going to give me 0. So do you see how it's going to fix my angle so that I get the original output, which is 0. So that's why my y's are easy to do. If you look at this one, if I sub it in there and I do the math, I'm actually going to get that angle being the tangent of that angle, which is nice because then I know the output is this. So I have to fix my x's so that when I sub them in, I get the original back. That's why we fix the x's. Now my y's, well, since I'm getting the original output or the original ratio, then I can just do what this function tells. That's the difference between x's and y's. X's I'm trying to manipulate so that after I sub them in, I get these values. And that way I get to keep my y values, which is really nice. All right, so these are all my new x values. So again, if you haven't written those down, you might want to do that. All right, and so we're going to go ahead and do our y's now. So I'm going to go ahead and erase those. All right, actually I might erase this middle part. Yeah, too much here. All right, we're going to just go ahead and erase all of this here. I'll give us some more space. All right, so here we decided to fix our y's. The fix for the y's was to just do what this said, so times by 1/2 and add 1. All right, so if I go back to my original y's, I'm just going to look at those for now. And again, those are just off the unit circle with the 45s added. I'm going to just, let me switch colors here so you can see this, but I'm just going to, take it times 1/2, add 1. Now again, do you see how that doesn't make any sense whatsoever? So that's still undefined. You're not going to do math to an undefined thing and expect to get anything good out of it. So again, that's still going to be undefined. All right, so to get my answer, I just do the math. So this guy is going to be 1 because obviously that's 0. This is going to be 1 1/2 or 3/2. Undefined still. This is a negative 1/2, so plus a positive 1, so that's a positive 1/2. This is 0, so that adds up to be 1. 1/2 plus 1 again is 3/2, and then of course undefined. This would be a negative 1/2 and add 1, so that's a positive 1/2. Again, that guy is 0, so I get 1. All right, so this is what I'm going to graph, all right, and you can kind of see where my bend is in my tangent function. This one, we don't have the previous one, but we can figure it out. But here I have a full bend, so obviously this guy would have to be a 1/2 up here, and this goes a 1/2 1. This guy's going to have to be 3/2. So even though I, didn't calculate them, I can still figure it out myself by just looking at it. All right, last thing, we're going to graph it. So let me go ahead and erase this, and again, hopefully you have those ordered pairs. You might want to pause it and go back. All right, so basically, if you look at our original chart, my original angle was -pi/6, and then 1 was my first one. All right, so again, I could graph that. All right, so let me see where, let me erase a little bit of that. All right, sorry about that. Let's start again. All right, so -pi/6 and 1, all right, was my first order pair. So, and then most of my units were in what, 12ths for my angles. So I'm going to have my angles be 12. So there's -pi/12. This is the -2pi/12. And again, if you want to label it -pi/6 to be nice, that is totally fine. But again, this is, when you graph, it's really for you. It's not for me. So grading wise, if, I don't really care how you do that. So let's see. I don't have any negative values. So up here, I have a 1/2. Let's see. We'll just go ahead and however we want to label these. All right. So we could label this, a 1/2 and call this guy 1 if we want to, or we could just have this 1 and keep track of things wherever. If you want this to be 1, this could be 1/2. You just decide. All right. So at -pi/6, which is this guy, right, or -2pi/6, I'm up at 1. So I'm going to put a dot there. At -pi/12, I'm at 1 1/2. So I'm right there. And at 0, so I'm just going through my points. So the next one was -pi/12 was 3 1/2 in my chart. And then the next point after that was 0, undefined. So at 0, I'm undefined. So that's where one of my asymptotes is going to be. All right, then my next one will give us a little better feel. So at pi over 12, I was at 1/2. So at pi over 12, which is this guy right there, I was at 1/2. Where's my half? There it is. There's my half. And then the next unit after that was 2 pi over 12. And that ended up being at 1, which again makes sense. So here's 2 pi over 12, and I'm up at 1. And then at 3 pi over 12, if I looked at my chart, I was up at 1.5, or 3/2, however you want to write that. Right, so up at 3/2, so where's that? Right there. And then at 4 pi over 12, I ended up undefined again. So again, I'm going to do my, here's my 4 pi over 12. So to graph this, again, it's going to go to infinity. It's going to bend and do that. And then over here, I can go back and be like, okay, well, this is 1.5, this is 1. So obviously, if I go over one more tick mark, this is here. And again, there would have been an asymptote on the other side of that. That goes there. And then I can just keep going. So I know that my next tick mark, because I know my units. So then, you know, this is what, 4 pi over 12. So now this guy's 5 pi over 12. Well, where's he going to be? Well, you know, he's going to match this guy. He's going to be right there. 6 pi over 12 is going to match that guy. 7 pi over 12 is going to be at 1.5. And then at 8 pi over 12, we're going to end up with an asymptote again. So again, I could, where am I at? 7, I think it's right here. I can draw another asymptote. And again, this guy goes to infinity. He bends right here. All right, so you can kind of see what the effect of the half is on the graph. And again, the effect of the period as far as how often it repeats, things like that.